Everyone wants to know how math, especially calculus, relates to their everyday life. Well, did you know the position you're at, the speed you're driving, and your acceleration all have to do with calculus? Scary, I know. So be sure to watch the video, subscribe, and share it with a friend, and I'm going to teach you how calculus and integration relates to position, velocity, and acceleration. You've already learned how to do position, velocity, and acceleration in terms of derivative, and if not, make sure you check out my video. So today we're going to talk about position, velocity, and acceleration in terms of integration. So here we go. Position is your S variable, velocity is your V, and your A is your acceleration. And I think you remember that when you take the derivative of position, you get velocity. So hopefully that goes to show if you undo them, you will get the opposite. If I take the integral of both sides, the integral and the derivative are exact opposites of each other. So that drops out. So you get that position. So you get that if you integrate velocity, you will get your position equation. Now let's do the same thing with velocity and acceleration. If you take the derivative of velocity, that's how you get acceleration. Well, if you integrate both sides, again, the integral and the derivative drop each other out, so you're left with that velocity equals the integral of acceleration. So for example, if you have acceleration and you need to get to position, you're going to integrate to get to velocity and integrate velocity to get to position. So let's try some problems. What better way than to start with a trig problem? So in this problem, they have given us our velocity. They're giving us our velocity. And they want us to find the position. So again, hopefully from the first page, you put all that in your notes. If we have velocity and we want position, we got to go backwards, meaning we're going to integrate. So we're going to integrate cosine of pi t dt, and that will get us our position. So what's our inside piece? Our inside piece here is pi t. What's the derivative of pi t? It's just going to be pi. We can't go ahead and change a problem, but we need that derivative of the inside piece to show up, and so out front I'm going to have 1 over pi as well. So when we integrate, 1 over pi stays. Derivative of the inside piece does not show up. Inside piece stays the same. Got to add a plus c. And we integrate the outside piece. In this case, we have to integrate cosine. What did we take the derivative of to get cosine? Hopefully it's sine. Very good. So this is our position equation. However, we have this plus c over here that we have to deal with. But they've given us some information we can use. When s equals 4, t equals 0. And this is our s equation, right? This is our position equation. This is position. So I'm going to go ahead and plug in 4 for s when t is 0 and solve for our c. So they said s is 4 when t is 0. So this is pi times 0 plus c. All right, so this becomes pi times 0. So we need to know where what sine is at 0. Well, here's our 0, which is 1 comma 0. Sine is our y value. So this whole piece goes to 0. And 0 times 1 over pi is just going to be 0. So our c will equal 4. Therefore, our position equation will be 1 over pi sine of pi t plus 4. And that would be your position equation. So in this problem, again, they want us to find position, and they gave us our velocity. So you have velocity, you want to go back to position, you got to integrate. So we're going to integrate 2t minus 3 dt. And this is nice, we can just do a straight integration. So when you integrate this, this is our velocity equation. We should write that. When we integrate, we're going to be getting our position equation. The 2 comes down, t, you add an exponent. So that's t squared, and then out front you do 1 over that new exponent minus 3t plus c. Now we can clean this up and plug in the information they gave us. When s is 1, they want it to equal 5. S of 1 equals 5. So I'm going to go ahead and plug that in. So this is going to equal 5, and these two are going to drop, and we're plugging in 1 for t. So you do some algebra here. 1 minus 3 is negative 2. Add it to the other side. C is 7. So you'll get that C is 7. Then you're going to plug your C in to the equation that we got when we integrated. So your S of t equation is going to be t squared minus 3t plus 7. Again, in this one, they want us to find the position equation, but they gave us acceleration, okay? So notice they gave you acceleration. You're at acceleration. How do you get back to position? You have to integrate twice, which is why you'll notice they gave us velocity information and they gave us position information. Because for each one of these, we're going to have to find out what that C value is. So we're going to integrate our acceleration equation, because that's what they gave us, right? We're going to integrate this to get back to velocity first. So the first thing, we're undoing the chain rule. Derivative of the inside piece is 2. Do we have that? Kinda. I'm going to rewrite this 4. So I'm going to rewrite the 4 as 2 times 2 cosine of 2t dt. So now this is the derivative of my inside piece. He will not show up in my answer, but this other 2 will. So when we go to integrate, this is going to become our velocity equation. This 2 comes down, he stays. This 2, derivative of the inside piece, does not show up. You leave your inside piece, and you integrate your outside piece. Again, what'd you take the derivative of to get cosine? Sine. So here is our velocity equation. But from here, we need to figure out what that C is. So we're going to use the information from above. We had this information right up here. V of 0 equals negative 1. So I'm going to plug in 0 for my t. Negative 1 is going to be what my velocity equation equals. We're going to solve for C. So they had V of 0 equals negative 1. That's how we're going to find our C value. So negative 1 equals 2 sine of 2 times 0 plus C. Negative 1 equals 2 times, now 2 times 0, 0, sine of 0. We just solved in the other problem. If you don't remember, go back and look at it. But if you need to know, it's right here. Ordered pairs, sine is going to be 0, so this is going to be 0 plus C, which means our C value is just going to equal negative 1. So now we can go back to our velocity equation and plug in negative 1 for C. So Vt equals 2 sine 2t, and C was negative 1. Remember, C was negative 1 over here? That was this business because that drops. Minus 1. This is your velocity equation. Now that we have our velocity equation, we have to integrate one more time to get our position equation. We're going to integrate velocity to get position. Sine 2t minus 1 dt. All right, now, derivative of the inside piece shows up, so that's great. We don't have to do anything with that. Remember, that will not show up in our answer. So when we go to integrate, we're now getting our position equation. When we go to integrate, the 2 does not show up. The inside piece stays the same. Then you integrate the outside piece. So what did you take the derivative of to get sine? Well, it's cosine, but the derivative of cosine is negative sine. And since we have a positive, that means our original has to be negative. So this would be negative cosine. We left the inside piece, derivative did not show up. Now we have to integrate this 1. That'll be a t plus c. And again, in the original problem, they gave us values for position to find our c value. They told us they wanted to use s of 0 equals negative 3. So I'm going to plug that in and solve for c. Negative 3 equals negative cosine 2 times 0 minus 0 plus c. Well, now we've got cosine of 0. So as we did up here before, here's our 0 position. Cosine this time is 1. So we'll have negative 3, negative, this whole guy is 1, minus 0 plus c. So c is going to equal, add 1, negative 2. So your position equation is negative cosine 2t minus t minus 2. And that would be your position equation starting all the way from acceleration. Now you're given a velocity equation and they want you to find displacement and distance. So there's two things you need to figure out here. One is displacement and distance, position, velocity, or acceleration. And hopefully that you know that distance and displacement is position. And if you didn't, get it in your notes. So anytime they talk about displacement and distance, they want your position. So now that you know they want position, they gave you a velocity equation. You got to work backwards, meaning we're going to integrate. That was the first piece of information you needed to know. So we know that we're going to integrate this velocity equation. The second thing you need to know is what's the difference between displacement and distance. So displacement is where you ended up. For example, you start at home, you go pick up a pizza, and then you go to your friend's house. Your displacement is actually the difference between your house and your friend's house because that's where you ended up. That's displacement. Only the distance between your starting and your ending point. Distance would be what your odometer in your car would read. So how many miles did you go from your house to the pizza place and then from the pizza place to your friend's house? Those are the two differences. So we've got two different problems here. So the first one we're going to do is I'm going to start with displacement. Because displacement just wants to know when we add everything up, where do we end up? That's just a straight integral. So we're going to integrate from 0 to 6, because those were the time bounds they were given, 2t minus 4 dt. When you integrate this, you get 2 1/2 t squared minus 4t, evaluated from 0 to 6. So these are going to drop out. We're going to do f of b minus f of a. So f of b is 6. So we've got 6 squared minus 4 times 6 minus a big old parenthesis, 0 squared minus 4 times 0. Well, that's convenient. That all drops out. 6 squared is 36 minus 24. You had a displacement of 12. So that shows you the displacement between where you started and where you ended up. Now they want to know your distance. So at some point you have to figure out when your car stopped and turned around and went the other way. The easiest way to do this is to look at the velocity equation they gave you. When does that thing equal 0? So when does this guy equal 0? Because then you know how to split up your bounds and when your car stopped and turned around and went the other direction. So we move the 4 over, you have t equals 2. So now what we're going to do is we're going to integrate and we're going to split up the bounds so we know how far your car went in each direction. So we'll integrate first from 0 to 2, 2t minus 4 dt. Now we have to add on the integral from 2 to 6, same integral, but we have to be able to show how far it went from 2 to 6. So we're going to integrate both. We've already integrated, so we know that this is t squared minus 4t, evaluated from 0 to 2, plus t squared minus 4t, evaluated from 2 to 6. I'm going to do the first part in green. So we have 2 squared minus 4 times 2 minus, now we're plugging in 0, 0 squared minus 4 times 0, plus 6 squared minus 4 times 6 minus, big old parenthesis, 2 squared minus 4 times 2. 2 squared is 4, 4 times 2 is 8, so 4 minus 8 is negative 4, minus 0, plus, this was from before, we had 36 minus 24, minus, over here you've got 4 minus 8 again, so minus a negative 4. So this part over here, we're going to have 36 minus 24 is 12, 12 plus 4 is 16. So this is where this is going to get a little tricky. It looks like negative 4 plus 16, which would give you 12. However, we're talking about how far you went, and pluses and minuses tell you direction. So we need to know that this one moved 4 units, and that one moved 16 units. So together, they moved 20 units. So your total distance would be 20. So basically, it's like saying these are absolute values because you want total distance. You don't care what direction you're going. So this would be 4 plus 16, which would give you 20 units. Now, if you wanted another way to look at this from the beginning, if you're going to forget this part, is if you go back up to the distance and you could put these in absolute values. Because distance is the absolute value. It doesn't matter what direction you're going. It wants you to find how many units you moved. For the next one, we're going to do a picture of a graph, but I want you to get something. This is a word problem. So, derivative is to slopes as integration is to what? You have to go back. Do you remember what is integration? And if you don't remember, check out one of my other videos. But integration is area under the curve. So when you are given a graph instead of an equation and you need to integrate, you need to look at the area under the curve. And that's what we're going to do next. So in this problem, they want us to find the total distance traveled when the particle starts at 2 and time is 0, and find where the particle is at the end of the trip. So the first thing you have to do is look at the graph. And if you see over on the y-axis, it's labeled with v. This is for velocity, and your x-axis is your time. So this is a velocity graph. And if we want to know position or where it ended up, if you have velocity, you need to go back to position, means you need to integrate. If you're integrating, you need to find the area under the curve. So that's what we're going to do. When we look at the area under the curve, hopefully you're recognizing that all this area under the curve makes a nice little shape called a triangle. So all we need to do is add up the area of a triangle. Remember, hopefully area of a triangle, 1/2 your base times your height. Add them all up to find how far we moved. So your base in these are all 1. Your height is all 2. 1/2 base and height. You're going to get an area of 1. So each of these areas are 1. So each of these areas, you fill all this in, all of these equal 1. Okay, I'm going to put a 1 right here so we remember. That's all the area under the curve. So 1, 1, 1, 1, a total of 4 units. That's how much you moved. Now, in the beginning though, it said the position started at 2. The position started at 2 when t is 0. All right. So the position started at 2 when time was 0. That's what it said in the beginning of the problem. So if you started at 2 and you moved 4 units, what was your total distance? Yep. Your total distance would be 6. And whatever the unit is. So 4 was how much you moved, 6 was your total units. Story problems, everybody's favorite. Okay, here we go. A ball is thrown up from a point 8 meters above the ground with an initial velocity of 49 meters per second. How high will the ball travel? deer in headlights, right? Like everybody for every story problem. So we're throwing a ball up from ground zero. So here you are, standing on the ground, throwing the ball up, and the ball will eventually come back down. That's my picture, right? We're standing 8 meters above the ground. Initial velocity is 49 meters per second. How high will the ball travel? That's like the bell curve of the ball, right? This is the point we want to know. We want to know how high the ball traveled. So when we're talking about direction, the ball's going to go up and then it's going to come back down. That's all velocity. We need to find out where that velocity is 0. However, the only thing we have is the initial velocity where it was thrown up. There's a fact of life that we have to use that's acceleration that will start this problem off. It's not even given here. So unless you know about this or have done an example, you might be a little stuck. But you're going to have to use gravity. Gravity is 9.8 meters per second squared, or if you're dealing with feet, it's 32 feet per second squared. Get that in your notes if you don't know it. Gravity, and if you notice your units here, this is your acceleration. Gravity is acceleration, and you can know that by the units because acceleration is a unit per time squared. Whereas you notice velocity over here is a unit per time, and position would just be a unit, right? Whatever, in this case we're dealing with meters. So we're going to have to start with our gravity for our acceleration, and we're going to use the 9.8 because this problem already gave us our units of meters. We're going to integrate our gravity to get to our velocity equation, and then we can go from there to get position to find how high the ball was. Here we go. We're going to integrate negative 9.8 dt. So this is our acceleration. It's negative because gravity's coming down. So when we integrate this, our velocity equation is going to be negative 9.8 t plus c. Well, they already told us that the initial velocity is 49. So initial velocity means t is 0. When they say initial, your time hasn't started yet. So when t is 0, your velocity equals 49. So we can plug this in and solve for c. So they said velocity was 49 when t was 0, which makes your c value, because this drops, 49. So our velocity equation is negative 9.8 t plus 49. But now we need position. So what do we have to do? Well, if you have velocity, you need to integrate to get position. So to get position, we're going to integrate negative 9.8 t plus 49 dt. So our position equation is going to equal negative 9.8, 1 over 2 t squared, plus 49 t plus c. Now we can plug in the fact that when t was 0, our position was 8. So I'm going to go through and do that. So our position was 8 when t was 0. I'm going to simplify this. It becomes negative 4.9. T is 0 plus 49 times 0 plus c. Well, that's nice again. These all drop out because they're zeros. And our c equals 8, which means our position equation is negative 4.9 t squared plus 49 t plus 8. So this is our position equation. And remember, what we want is the position of the ball at the top of the curve. And do you remember what we talked about at the top of the curve? So I'm going to draw it here. Here's the curve. At the top of the curve, this is where velocity equals 0. So we have our position equation, but we have to find out at what time does velocity equal 0 to plug into our position equation to find that. So let's take our velocity equation and set it equal to 0. So this is our velocity equation. We're going to set this equation equal to 0 and solve for t. So I'll move my 9.8 t to the other side so I can deal with positive numbers. and divide both by 9.8. And t is going to equal 5. So now what we do is go through and put 5 in for t in our position equation to get our height of the ball. So I'm plugging 5 into the t. So s of 5, so negative 4.9, 5 squared plus 49 times 5 plus 8. When you plug this into your calculator, you're going to get 130.5 meters. And that's the height that the ball will travel when thrown up. So hopefully you see how calculus is used in everyday things like position, velocity, and acceleration. Like it or not, it's there. Be sure to subscribe, share this video with another calculus friend so they too can understand how to use calculus in everyday life.